Hydrosphere. Meaning of hydrosphere: tides, formation and pattern, effects and importance of tides we are going to learn today. Meaning of hydrosphere. Hydrosphere is the total amount of water on the planet. The hydrosphere includes water that is on the surface of the planet, underground and in the air. Hydrosphere can be liquid, vapor or ice. On Earth, liquid water exists on the surface in the form of oceans, lakes and rivers. Water covers 71% of the Earth's surface. Out of that, 97% is ocean water or sea water, which is salty. Remaining 3% is for our use. Out of this 3%, 2.3% that fresh water is locked up in glaciers, polar ice caps, and out of that 66.66% groundwater and 0.04% to 0.03% is for our surface water to use. This supply is continuously collected, purified, distributed in the natural hydrologic or water cycle. Sources of fresh water: it can be ice sheets or streams or rivers or lakes or reservoirs or glaciers or groundwater or marshy areas also. Fresh water is generally characterized by having low concentration of dissolved salts and other total dissolved solids, and that's why as it is having less dissolved salts, it is usable. Groundwater. When rain falls, some of it is immediately evaporated. Some of it is absorbed by plants and gradually transferred from the leaves. Much of it is flowing into the rivers and streams. A considerable amount of water received from rain or snow percolates into the soil and rocks known as groundwater. Water table. Water which seeps into the ground or percolates into the ground reaches impermeable layer of rocks. If there is no ready outlet, like here, there is no ready outlet. But over here, you are getting in the upper layer, you are getting ready outlet. And so we are getting streams. Spring is coming from these particular areas. And from this spring, the streams are flowing on the surface. But if there is no outlet, then the rock layer that is above the impervious rock, the water gets percolated and it is known as aquifer. And the surface of the saturated layer of water is known as water table. The depth of water table varies from season to season, from types of rocks, etc. Water cycle, also known as hydrological cycle. It is a continuous movement of water from one state to another by physical process like evaporation, condensation, and then precipitation. And again through the surface runoff, again evaporation is taking place, again condensation, and then precipitation. It's a continuous cycle. Tides. Tides are the daily rise and fall of Earth's water level on its coastline. There are two high tides and two low tides. Types. Which are the types? High tides and low tides depending on the water level. As the tide is coming in to the shore, the level of water on the coast rises, As the tide goes out, then the water level goes down. Tide occurs in all bodies of water, but it is noticeable in ocean and large lakes like Caspian Sea and all. Now, high tides when the water is reaching to its highest point, and low tide when the water reaches to its lowest point. What causes tide? Tides are caused by the interaction between Earth, Moon, and Sun. The gravity exerted on the Earth's ocean by the Moon and Sun causes the water to swell up. Now, the Moon is much more closer to Earth than the Sun, and so Moon's gravitational force is more on the tides. And that's why we generally say because of the Moon's gravitational force, the tide has caused. But it is actually Moon as well as Sun. Both are pulling and having effect on the Earth's surface, especially the liquid, that is the water surface. Another factor is centrifugal force. When Moon or Sun are pulling the Earth's water surface in one side, the other side also bulges, and that is because of the Earth's centrifugal force on the opposite side of the direction of Moon. Tide occurs due to this kind of tides. It occurred due to the balance, that is the inertia. We have learnt in physics also law of inertia. Here is the law of inertia. Now, gravity is the force. What is gravity? Just now we are telling about the moon's gravity and sun's gravity. What is gravity? It is the force exerted by any object that pulls other object towards it. The moon pulls on the water on one side nearest to it. This pull creates bulging of the water. And as we have learned, opposite sides, because of the theory of inertia or law of inertia, the other side also gets bulged. Tidal bulges. Where it is bulging towards the moon or the opposite side, there we are getting high tide. Where there is tidal bulge, high tide is occurring at the coastline. In places between the high tides, in between, we are getting low tides. Why are there two high tides and two low tides? One bulge is towards the moon, the other bulge is opposite side of the moon. Why? Now you can see this particular game, or you can say recreation. If you ever have felt or enjoyed this particular the carousel spun, then you will feel something is pulling you out of the center. You try to come out of the particular area, and that's the same thing when the moon is also rotating, earth is also rotating, one side is bulging, but as the earth is rotating, the other side is also, because of the centrifugal force, bulging out, and combined way we are getting two high tides on opposite directions. Tidal range. Tidal range is the difference between the level of ocean water between the high tide and the low tide. If this is the mean sea level, then this one will be the high tide range and this will be the low tide range. We are talking together, it is tidal range. Sun's gravity is also acting on us. Sun is so large that its gravity also affects us. The tides. At times, the sun and moon pull together on Earth's water in the same direction, whether it is full moon or new moon. And some other time, it is pulling in different direction. Monthly tidal cycle. Changes in the position of the Earth, Sun and Moon affect the height of tides during a month. The position of both the Sun and the Moon in relation to Earth has direct bearing on tidal height. Spring tides. It occurs 2 times a month during the full moon and new moon. Full moon time, the Earth and Sun and Moon is in the same line, nearly the same line. So one side Moon is pulling and the Sun is pulling. So together the gravitational pull is equally working on Earth's surface. In the new moon also the pull is maximum because Earth is one side and Moon and Sun are pulling the water towards their side. So it is maximum. But during the neap tide, when Earth is in the middle, one side is Moon and one side is Sun, that is nearly 90 degrees. That time what happens? They tend to counteract each other. Who? Moon and the Sun. The Moon's attraction is diminished by the counteracting of the Sun's gravitational pull. So neap tide is weaker and spring tide is stronger. Here we can see the same thing, spring tides and the neap tides over here. Suppose this is the mean sea level and the general height should be this one and general low tide will be this one. But during the spring tide, the water springs up to this level, nearly 20% up or nearly 20% down. So we are getting highest neap tide, highest spring tide and lowest spring tide. The moon, the movement of water towards and away from land with the high and low tides respectively generate tidal currents. Flood current is the flow of water towards the land, whereas ebb current is away from the land. Electricity can be generated from tidal currents if the tidal range is greater than 5 meters in a large bay connected to the ocean by a narrow opening, especially in western countries and as well as in India near Sundarban, it has started. Each day, a tide is delayed by 26 minutes. Now look at the GIF over here. The moon is also rotating and as well as revolving around the earth. At the same time, earth is also spinning around its axis. So, each day a tide is delayed by 26 minutes because the moon is also rotating on its axis. It is also west to east and earth is also west to east. So, what is happening? The tidal center shifting towards the westward. When tide center completes one round, the moon's position is ahead of the tide center by that time. If you observe over here, moon is not always at the same facing the same point. Moon is now, suppose moon is facing this America. Then what happens? But not always America, it can be Russia also. So it is changing its position towards the west continuously. And that's why the tidal center takes another 52 minutes to come under the moon. Thus, a particular tide center takes 24 hours, 52 minutes to come under the moon. But by that time, there is another tide in the opposite side of the refer tide center, and this happens 12 hours 26 minutes. If you divide 24 hours 52 minutes, you are getting 12 hours 26 minutes. Two times in the same place you are getting high tides, and two times you are getting low tides. Just we have learnt about the ebb and flood. Ebb is going back of the water and flood is coming towards the shore. Importance of tides. Since tides are caused by the earth, moon, sun positions, which are known accurately, the tides can be predicted well in advance. This helps the navigators and fishermen plan their activities. Navigation. High tides help in navigation. They raise the water level close to the shores. This helps the ships to arrive the harbor, especially near rivers, mouth and within the estuaries more easily. Tides generally help in making some rivers navigable for ocean-going vessels like London in the Thames River or Kolkata Hooghly River, Kandala in Gujarat are important tidal ports. Fishing. The high tides also help in fishing. Many more fish come closer to the shore during the high tide. This enables fishermen to get a plentiful catch. Desilting. Tides are also helpful in desilting the sediments and removing polluted water from river estuaries. To generate electricity. Tides are used to generate electricity. A tidal power project was constructed at Durgadwani in Sundarbans in West Bengal. Thank you.